Good morning to all of you. First of all, I want to introduce myself. Myself Ankit Acharya, working as an assistant professor in Hasmukh Goswami College of Engineering, and today my content is GTU question paper solution of the subject of vector calculus and linear algebra of June 2014. So let's see. The question number 1 we already seen in this question paper. So this is the subject vector calculus and linear algebra, GTU paper solution 2014. So this is question 1 we already seen last time. So let's see, start with question 2. Here is a question 2a. We have to solve this linear system of equations. There are four equations and 4 variables. So here is a question: solve the following system of equations using Gauss elimination method. So there are 4 equations: 2x1 plus x2 plus 2x3 plus x4 is equal to 6, and 6x1 minus x2 plus 6x3 plus 12x4 is equal to 36, 4x1 plus 3x2 plus 3x3 minus 3x4 is equal to 1, 2x1 plus 2x2 minus x3 plus x4 is equal to 10. This question was asked in 5 marks in this question paper. So first of all, we have to write down the augmented matrix for the given equations. And what is the augmented matrix? See, the first row in this matrix, the first row is coming from the first equation. You can see the coefficient of x1, x2, x3, x4 in the first equation, that is 2 1 2 1. So this is 2 1 2 1. Then the coefficient of x1, x2, x3, x4 from the second equation, that is 6 minus 1 6 12, right? 6 minus 1 6 12. The coefficient of x1, x2, x3, x4 from the third equation, that is 4 3 3 minus 3. So the third row is 4 3 3 minus 3. And the coefficient of x1, x2, x3, x4, that is 2 2 minus 1 1, 2 2 minus 1 1. So 6 36 1 10, 6 36 1 10. Now we have to convert this augmented matrix into a row echelon form matrix. Now first of all, what is the meaning of row echelon form? Here we have to solve this system of equations using Gauss elimination method. So that's why we have to convert the given matrix into row echelon form. If suppose in this question, if asked that solve this system of equations using Gauss-Jordan method, then we have to convert this augmented matrix into reduced row echelon form in that case. Okay, now what is the meaning of row echelon form and reduced row echelon form? If suppose there is any matrix, right, any size of matrix, there are some conditions to become a row echelon form matrix. The first condition is, if there is any 0 row, it should be the bottom of the matrix, right? If there is any 0 row, that means if there is any 0 row, if there is any row contains all elements are 0, then it should be always bottom of the matrix. If there is any leading entry means the first non-zero element of that row, right? That is called leading entry of that row. Now below that leading entry in that particular column, all the element should be 0. That is our second condition. And the third condition is, whenever we are going from above to below in any matrix, our leading entry is always going from left to right, right? So if these 3 conditions are satisfied, then we can say that our matrix is in row echelon form matrix. Now if we add 2 more conditions in these 3 conditions, suppose the fourth, let the fourth condition is our leading entry must be 1, right? That is our fourth condition. And the fifth condition is, if there is any column contains a leading entry, or sometime we call pivot, in that particular column, except the leading entry, all the elements should be 0. In that particular column, except the leading entry, all the elements should be 0. So If these 5 conditions are satisfied, then we can say that our matrix is in reduced row echelon form matrix. Now here you can see this is our augmented matrix, and we want to convert this matrix into a row echelon form matrix, because we have to solve this system of equations using Gauss elimination method, right? So let's see how we convert this matrix into a row echelon form matrix. The first process is we convert first row with -3 and add into the third row, and we convert first row with -2 and add into the we convert first row with -3 and add into the second row, and we multiply first row with -2 and add into the third row, and then we multiply first row with -1 and add into the fourth row, right? So these are the next processes. You can see the first row is as it is 2 1 2 1 6. The second row is now become 6 minus 6 0, then -1 -3, that is -4. You can understand from this matrix, right, how we change all the elements in the second row. That is 6 minus 6 0, then 12 minus 6 6, and 36 minus 18, that is 18. So these are the second row, 0 minus 4 0 9 18, right? 12 minus 3, sorry, here this 12 minus 3, that will become 9. Now we multiplying first row with -2 and add into the third row. So the third row become now 4 minus 4 0, now 3 minus 2, right? Just try to understand, we multiplying first row with -2 and then add into the third row. So now our third row become 4 minus 4 0, then 3 minus 2 1, then 3 minus 4 minus 1, and then -3, -3 minus 2, that is -5, and then 1 minus 12, that is -11. So now this is our third row, 0 1 minus 1 -5 -11. Then multiplying first row with -1 and add into the last row, fourth row. So 2 minus 2 0, then 2 minus 1 1, then -1 minus 2 -3, 1 minus 1 0, and 10 minus 6 4. So 0 1 minus 3 0 4. So 0 1 minus 3 0 4. Now we are interchanging second and third row. 2 1 2 1 6, and the second row is now 0 1 minus 1 minus 5 minus 11, 0 minus 4 0 9 18, right? The last row is as it is, 0 1 minus 3 0 4. Now next process is we are multiplying second row with 4 and add into the, because now see this is our leading entry, in the first row this is our leading entry, below that leading entry we have all the 0. Now in second row this is our leading entry, this 1 is our leading entry. Now we want to make below that leading entry we want to make 0, so that's why we are multiplying second row with 4 and add into the third row, and multiplying second row with -1 and add into the fourth row, right? So the next processes are, you can see, just first and second row are as it is, the third row becomes 0 0. Now multiplying with 4, so this is -4 plus 0 -4, then -20 plus 9, that is -11, and 4 -11 into 4, that is -44 plus 18, so that will become -16. So that's why right, multiplying -44, right, plus 18, so this is -26. So the third row is now 0 0 -4 -11 -26, and then also we are multiplying second row with minus 1 and add into the fourth row. So the fourth row is 0, 1 minus 1 0, minus 3 plus 1, right? So that is minus 2, then 0 minus 5 5, and 4 plus 11 15. So that is 0 0 minus 2 5 15, right? So now you can see again let's see, is this matrix a row echelon form matrix? Let's see. This is our leading entry. Below that leading entry we have now 0. In second row this is our leading entry. Below that leading entry we have 0. In the third row this is our leading entry. Below that leading entry here we have to make 0, right? So that's why we are multiplying. Okay, first of all we are interchanging third and fourth row, so it's quite easy to make 0 below that leading entry. So let's see, R3 4. So the third row become fourth row and fourth row become third row. First and second row are as it is. So the new matrix is 2 1 2 1 6, then 0 1 minus 1 minus 5 minus 11, 0 0 minus 2 5 15, and the last row is 0 0 minus 4 minus 11 minus 26. Now we are multiplying third row with minus 2 and add into the fourth row, right? So the new matrix is now you can see fourth row become now minus 4 plus 4 0, then minus 11 minus 10, that is minus 21, and then we are multiplying with minus 2, right? So minus 11 minus 10 minus 21, and then minus 26 minus 30, so that will become minus 56, right? Think. So this is minus 21 minus 56. Clear? So now you can see this matrix is now in row echelon form. There is no 0 row. Okay, so we don't need to convert that 0 row into the bottom of the matrix. Our leading entry is going from left to right. How many leading entries? There are 4 leading entries. You can see all are in diagonal elements that are our leading entry. Not always, but in this case. So and leading entry is going from left to right whenever we are going from above to below. So this matrix is satisfied all the conditions to become a row echelon form. So now we can easily solve the given system of linear equations from this augmented from this row echelon form matrix. Our equations are 2x1. From the first row we have 2x1 plus x2 plus 2x3 plus x4 is equal to 6. Then from the second row x2 minus x3 minus 5x4 is equal to minus 11. Then minus 2x3 plus 5x4 is equal to 15. Minus 21x4 is equal to 56. Okay. Now, so from the last equations we get the value of x4. x4 is equal to 56 divided by 21. So that will become 7 by 4, correct? Because 56 and 21 both are in multiplication of 7. So 7 into 8 56 and 7 into 3 21. So that's why that will become 7 by 4. x4 is equal to 7 by 4. Then x3 is equal to 3 by 2. When we put the value of x4 in these equations, x3 is equal to 3 by 2. x2 is equal to minus 5 by 6 and x1 is equal to 8 by 3. Okay, that we can easily solve because right, put the value of x3 here, so you will get value of x3. Then when we put the value of x3 and x4 in these equations, we put the we get the value of x2 and then x1. Okay, so it's quite easy to solve these equations now. So this question is complete here. Next question, question 2b. Find the inverse of this 4 cross 4 matrix using Gauss-Jordan method. This question was asked in 5 marks. Here we have 4 cross 4 matrix. That means we have 4 number of row and 4 number of column. The first row is 1 2 3 1. The second row is 1 3 3 2. The third row is 2 4 3 3, and the fourth row is 1 1 1 1. So how we solve this example? See, using Gauss-Jordan method, if you want to find inverse of any matrix, we have to write down first of all left hand side the given matrix, our original matrix, and the right hand side we have to write down the identity matrix of the same size of the given matrix, right? So you can see this is our original matrix, and now the right hand side we write down here identity matrix of the size of 4 cross 4. Okay, now what is our next step? Using row operations, we convert this identity matrix into the left hand side, and whatever the matrix in the right hand side, that is our inverse of the given matrix, right? So now you can understand how we doing row operations. Okay, so definitely for identity matrix we need here 1, and we have already 1, so that's why we are multiplying this first row with -1 and add into the second row. Then we are multiplying first row with -2 and add into the third row, and then we are multiplying first row with -1 and add into the fourth row. So below that 1 in the first column we have now all 0, right? So let's see what makes difference in other elements. Multiplying first row with -1 and add into the second row, also multiplying first row with -2 and add into the third row, and multiplying first row with -1 and add into the fourth row. So the first of all one by one we see all the rows. Okay, you can see first of all we are multiplying first row with -1 and add into the second row. So let's see, second row become now 1 minus 1 0, 3 minus 2 1, 3 minus 3 0, and 2 minus 1 1, right? So this is 0 1 0 1, you can see, correct? 0 1 0 1, right? Now right hand side 0 minus 1 minus 1,